Welcome. Today we will take the red pill and go down the rabbit hole and enter the matrix. That's right, we will start discussing matrices, which is the plural for matrix. So, in front of you, you have a matrix. And this matrix here is defined as matrix A. And we always use capital letters when we are talking about defining matrices for variables. And we have a series of numbers here to the right in these brackets, which denotes the matrix itself, as it's what it's defined here. And it's comprised of rows and columns. So here we have 2 rows and 3 columns, and we can number these rows like this would be row 1, and this is row 2. This is column 1, column 2, and column 3. So if we're looking at a particular number, it's called an element. So for example, this 5 is an element. It's the element in the first row, 3rd column. So that's how we read matrices. Now matrices can be of different dimensions. You can have a different number of rows and a different number of columns. This particular one, what we call it is a 2 by 3 matrix. We state the number of rows first, and then the number of columns. Okay, so that's a matrix. Let's discuss about how you use them. So the first operations we're going to talk about is adding and subtracting. And basically it's very, very straightforward. Each element corresponds, in the first matrix, corresponds with the element in the second matrix. So, for example, if I'm adding this 2 by 2 matrix with this 2 by 2 matrix, I'm going to add the first, the 1, 1 element, first row, first column of the first matrix of the 1, 1 or first row, first column element of the second matrix, and we just add them together, so it'll just be A plus E, and then we each thing will correspond. And subtraction is the same thing, except we're just going to be subtracting each of these elements. Okay, so let's actually do this. So I have a matrix 2 by 2, and I'm adding another matrix 2 by 2 to it. So here's how we do that. So I'm going to start off equals, and I'm going to have 2 and -3, so that's going to give me -1. And then 4 plus 2 gives me 6. Now I'm going to add the 0 and the 4, which gives me 4, and the 1 and the 0, and that's going to give me 1. And that's it. Easy enough. So that is our sum. Now, for subtraction, you want to be a little bit more careful because we are dealing with sign changes. So these are this is a 3 by 2 matrix, and this is a 3 by 2 matrix. And we can, the first thing I want to do is I'm going to change this to addition, and I'm going to go in and change all these signs so that it makes it a lot easier to keep track of everything. Now, one thing I want to point out is that you can only add and subtract matrices that have the same dimensions. Like, I can only add this 3 by 2 matrix with this another 3 by 2 matrix. I can't do a 2 by 3 matrix or a 3 by 3. They have to have the same dimensions. Okay, so let's go and get started. So I'm going to add the 4 with the -2 now, which is going to give us 2. And then we get 3, 2, 0, 4, and 4. And there is our new 3 by 2 matrix. The next thing I want to do is I want to throw in another operation here. I have a number in front of this matrix, a -3. Now, when you're multiplying a single number with a matrix, that number has a name. The name of this one is the name of that number is a scalar. Okay, and a scalar is simply just that, a single number multiplying with a matrix. And it works kind of like the distributive property. We multiply the scalar with everything inside the matrix. We start off with our scalar multiplication. I'll have I'm going to go ahead and have +3, and then I'm going to multiply the -3 with the 5, and that's going to give me -15, and then -12, and then -3 and 0 is 0. Okay, bring down the other 2 by 2 matrix, -2, 5, 1, -3. And now we just add these two matrices together. So I have what's going to be 1, -14, -7, and -3. And there's our final answer. So all the operations or the properties of matrices are similar to those that we deal with just dealing with real numbers. Just note that we're using capitals here to represent the matrices as opposed to lowercase variables. So we have the associative, the commutative properties, but the distributive property here is with, again, a scalar, and since that's a single number, we denote that with a lowercase k. So for instance, here I have matrix A plus matrix B. Well, I can distribute this scalar to both terms here, and then I could add them together. So that's something we can use to our advantage. So anyway, those are the properties. Now let's go ahead and apply a scalar, and we're going to actually take this a step further, and we have a couple variables in here, and we're going to solve those variables. For instance, I have an x here I want to solve for, and a y here I want to solve for. So the first thing I want to do is go ahead and, well, I could distribute the scalar to everything, so we'll use that distributive property and rewrite it. So this becomes 4x minus 6, 10, -2y, and then we're going to multiply the scalar with the second matrix, plus -1, 4, I'm sorry, let's go back, got to actually multiply it. That's going to be -2, 8, 6, and 10 equals this matrix, 10, 2, 16, and 14. Okay, so if you look at this, this is very similar to, you know, how we might write an equation, except we're just using, matrices. So like this is matrix A, we're adding in matrix B, and that's going to equal matrix C. So we're going to use that to our advantage to solve these individual matrices. So I'm going to go ahead and add these matrices together. So I'm going to start off with 4x, and I'm going to add that with the first element here in matrix 2, or matrix B, and that's going to give me 4x minus 2. So that whole expression is in the first element of our new matrix. And then I'm going to add the negative 6 with the 8, and that's going to be 2. And then 16. And then here we have the 2y, the negative 2y, and the 10, and we'll add those together, and that whole expression will go into our last element, row 2, column 2. So negative 2y plus 10, and there's the sum, equals 10, 2, 16, 14. Now that we've simplified everything on the left, we take a look at what we have and notice that here, my first element here, I have 4x minus 2. On the other side, we have a 10 as the first element here. These two elements correspond, and I can just put an equal sign there. So I'm going to rewrite this as a regular equation. I'm going to pull those out. I'm going to pull those numbers out of the matrix and just write a simple expression. So I'm going to have 4x minus 2 is equal to 10. And I can also do the same thing with this one. This corresponds with the 14 in this matrix. So I'll be left with negative 2y plus 10 equals 14. Now we just solve them. So I'll add 2 to both sides. I have 4x equals 12, divide by 4, and x is equal to 3. And our next one, I'll just subtract 10 from both sides, leaving me with negative 2y equals 4. Divide both sides by negative 2, and I have y is equal to 2. And I have solved for both my x and my y. So that's how you can solve for variables in matrices. So at this point, I'm going to unplug the matrix and see you on the flip side.